When you hear the word hacker, what comes to mind? Probably some person in a dark room, right? Breaking into systems. But what if I told you that the very same tools they use are actually some of our most powerful instruments for defense? Yeah, okay, so let's get into it and take a look inside the professional toolkit of an ethical hacker. And that, right there, that really gets to the heart of it. The tools themselves, they're totally neutral. It's the intent behind them that changes absolutely everything. It's not about the tool, it's about the hands that are using it. So I want you to try and think about this toolkit a little differently. Don't see it as a weapon. Instead, think of it more like a diagnostic instrument. Like a workbench full of specialized gear, or maybe even a doctor's bag. Every single tool in there is designed to examine a system, to find what's wrong, and then to figure out how to make it healthier and a whole lot stronger. And the professionals who use these tools? Well, they're often called penetration testers, or just pen testers for short. Their entire job, really, is to think like an attacker, but act like a defender. They find the cracks in the walls so you can seal them up long before a real burglar even thinks about coming to knock. Okay, but before we even think about opening that toolbox, we have to talk about the single most important rule in this entire field. And it's not a technique, it's not some fancy trick, it's a principle. You must have permission. Without it, you're not a tester. You're a criminal. Simple as that. So this is the crucial difference, and it is crystal clear. You've got an ethical hacker on one side. They have written authorization. Their goal, to make security better. And what's the outcome? A detailed report for the client. Then you have the malicious attacker. No permission. Their goal is to exploit, to damage. And the outcome? Well, it's theft, disruption, chaos. The actions might look similar on the surface, but the context, the permission, that changes everything. All right, with those rules of engagement firmly established, let's start our security checkup. The very first step is what we call reconnaissance. It's all about gathering information, mapping out the system, really just trying to understand what we're looking at. It's just like a doctor taking a patient's vitals before doing anything else. These first tools help us build a kind of digital blueprint. You've got Nmap, that stands for Network Mapper, and it's like a security guard methodically checking every single door and window, which we call ports, to see which ones are open or unlocked. And then you have something like Shodan.io, which is, well, it's like a super specialized Google for every device connected to the internet. We're talking servers, webcams, you name it. It shows us what's visible to the entire world. This is our first layer of intelligence gathering. Okay, so once we have that map, we bring in the scanners. Tools like Nikto and Nessus, what they do is automatically check for thousands of known vulnerabilities or common mistakes in configuration. Think of it like a doctor running down a checklist of common symptoms, just looking for known issues that could cause big problems later on. Now we're moving from just passively scanning to more active testing. And I know, this is the part where people can get a little nervous, but you have to remember, this is a controlled diagnostic test. It is not a destructive attack. We're just carefully poking at the weak spots we found to confirm if they're actually a problem. This is where these really powerful frameworks like Metasploit come into play. It's basically a massive library of safe, simulated attack methods. We can use it to test if a theoretical weakness can actually be exploited to get access. See, it's the difference between seeing a lock that looks flimsy and then gently checking if it can be picked. And this is so important. This is all done in what we call a sandbox. It's a secure, isolated environment where our tests can't possibly affect the real live system. So, okay, what does this actually look like in practice? Let's run a super quick, super simple example. I'm going to use one of the most basic tools, Nmap, to just scan my own local machine right here in my completely safe lab environment. And I really have to stress this. You would never, ever do this on a live network without explicit written permission, ever. So yeah, even a simple command like that can reveal a pretty surprising amount of information. In a real-world scan, you'd see a list of all the open ports, the services running on them, maybe even the version of the operating system. It's a perfect small-scale example of how an ethical hacker can gather crucial intelligence, quickly and more importantly, harmlessly. It's all part of that diagnostic checkup. But you know what? Finding a vulnerability is only half the battle. In fact, you could argue it's not even the most important part. The real crucial work actually begins after the test is over. It's all about documenting the findings so the organization can heal itself. And this right here, this just brilliantly illustrates that key difference we talked about. A malicious attacker's work is done the second they get in, but for an ethical hacker, their work is just beginning when they find a way in. Because their final product isn't a breach, it's a comprehensive report. It's a blueprint for building much stronger defenses. And that brings us to the final and honestly the most critical piece of this whole puzzle. It's not really about the tools you use, it's about the questions you ask. It's this hacker's mindset that truly separates a professional from someone who's just blindly running scripts. A true professional, they don't just find a vulnerability and celebrate. No, they stop and they ask the first critical question. Why? Why does this exploit actually work? What is the fundamental mechanism here that's allowing this to happen? And that leads them directly to the next question, which goes even deeper. Okay, so we know why it works, but what was the underlying design flaw that made this vulnerability possible in the first place? See how we're moving from just the symptom to the root cause? And finally, this leads to the most important question of all. This is the one that defines the entire purpose of this work. How can we fix this systemically? How can we prevent this entire class of problem from ever happening again? This is about finding a cure, not just putting a bandage on a symptom. So in the end, these tools, they're just lenses. That's all they are. They allow us to see our own systems from an attacker's perspective. And that knowledge isn't dangerous, it's power. It's the power to understand your own weaknesses, to strengthen your defenses, and ultimately to build a more secure digital world for every single one of us.